Parent functions are what we're going to talk about today. Parent functions and transformations. Basically, where they come up with the name parent function is that what the function can do is have lots of different offspring, but yet they still have the same basic characteristics. And so that's why they call it a parent function. Okay, so you start off with your parents, and then you've got your children below. They have the same characteristics as their parents, okay, but yet they are different. So here, we have the linear and polynomial parent functions. You're going to have to memorize these. Okay, so the first one is a constant function. A constant function is just a horizontal line. That's all it is. A constant function is a horizontal line. Now, one of the things you're going to have to be able to do is identify these. So you're eventually going to have a quiz, probably Wednesday, maybe Tuesday of next week. I'm going to give you pictures of the graphs, and you're going to have to identify them. A constant function is a horizontal line. It takes the form f of x equals c, where c is any number. So an example of a constant function would be f of x equals 1, f of x equals 2, f of x equals negative 3.5. So it's going to be f of x equals 1. Now just a little tidbit, you could also have y equals something, like y equals 2, because remember, y and f of x are synonymous. So that's your first function, constant. Your next one is the identity function. The identity function, if you notice, is just a line. And it's the line f of x equals x. So let's review a little bit about that line. What can you tell me about the line f of x equals x? Has slope what?
Positive.
If the slope is positive, what else is the slope?
Slope is 0.
Slope f of x equals x. What is the slope value of that line? 1. What is the y-intercept? 0, because if you remember, this is in the form mx plus b. Okay, mx plus b, that is slope-intercept form. So in this case, m is 1, b is 0. So that's the graph of the identity function. It will have a slope of 1 and a y-intercept of 0. So slope 1, y-intercept of 0. The quadratic function, and you've heard me use the word quadratic over and over and over again. Quadratic means x squared. So that's what you have to look at. It has a U-shaped graph. That is the parent function. F of x equals x squared. The cubic function, f of x equals x cubed. That is what it looks like. Okay, kind of like a sideways S. So first of all, those are 4 parent functions. We have the constant, we have the identity, we have the quadratic, and we have the cubic. So you're going to need to identify pictures of all 4. And trust me, we've got more coming.
There's a lot more coming?
Yeah.
What do you mean more coming?
More pictures on the next slide.
My favorite.
So we're going to go ahead and look on the next slide. It's in your book on page, you can follow along too, on page 45. And that's where these next ones are as well. So page 45, if you want to follow along. The next 2 that we're going to look at are the square root and the reciprocal function. Okay? The square root function, f of x equals square root of x. We know that the square root is related to which other parent function? What's the square root related to? Yeah, the quadratic, the x squared. Because you know the quadratic and the square root undo each other. So the square root function looks real similar to the quadratic. What you don't see is you don't see the bottom part of the quadratic graph. The reason being, you can't get a negative answer here. So that's why you only see the top part. But that's the relationship between the quadratic and the square root function. The reciprocal function, 1 over x. So we've got 6. Constant, identity, quadratic, cubic, square root, reciprocal. And we've got more coming. Okay, so those are 6 so far.
We have 14.
Here are 2 more. We have the absolute value. Absolute value is a v. V. So that should be easy to remember. You see a v, absolute value. And then we have the greatest integer function. The greatest integer function looks like what? Stairs. And actually we call this a step function. So the greatest integer function is called a step function because it looks like stair steps. So real quick, what we're going to do right now is graph that on our graphing calculator. And you're going to see how it looks like on your graphing calculator. So go ahead. Now, where do you find the greatest integer function? Okay. There's 2 places to find that. Okay. Actually, I take it back. There's only one. You're going to go to the Math menu. You're going to go over to Number. So the Math menu is located down by the green alpha key. Go over to Num, and you're going to notice number 5 says INT. Okay, that means greatest integer. So you're going to put INT, and then you're going to put X in parentheses. So you're going to go to Math. You're going to go to Num, and then you're going to find the INT, and then that is what the greatest integer is. So if you put that in, your y equals integer of x, and you hit graph in the Z standard window, you're going to see something that looks like a stair step. Okay? Yep, go to graph. Yep, and then go to graph. So there you go. That is what the stair step function looks like. Okay?
Pretty good.
Okay, so let's go ahead and look at this. It says describe the following characteristics of the graph of the parent function f of x equals root x. This is what they want you to do. Domain, range, intercept, symmetry, continuity, and behavior in intervals on which the graph is increasing or decreasing. So first thing we're going to do is graph. So let's go ahead and graph that function. Square root of x. And all we're going to do is go through these individually. It sounds a lot worse than it actually is. So the first thing is the domain. The domain is the set of x values. So what x's work on this graph? They all work? All the positive ones, right. So let's figure out, let's use interval notation here. Which is the leftmost point that we use for x?
0.
0. Do I include 0?
Yes.
So I'm going to start with 0. What is the rightmost point on the graph?
Infinity.
Infinity. So again, domain, remember, domain was left to right. There you go, you're done with domain. Okay. What was range?
Range is top to bottom.
Top to bottom. Okay, so on our graph, okay, what is the lowest point on the graph?
0.
0. Do I include it or not?
Yes.
So 0. What is the uppermost point on the graph? Infinity.
No, because it didn't go down.
So really, remember, domain was left to right. Range was bottom to top. And that was one of the first things we learned. Okay, domain and range. Now what we're going to do is we're going to talk about intercepts. So if I look at the graph, do I have a place where it intersects the x-axis? Yep. Where does it intersect the x at? 0. So I have an x-intercept of 0. Do I have a place where it intersects the y-axis? 0. That's it. Symmetry. Does the function have x-axis symmetry? No. Y-axis symmetry. Origin symmetry. Symmetry, there is none. Continuity. So if I start on the graph, are there any holes or breaks in the graph? No. Continuity. Yes, it is continuous. End behavior. Okay. First of all, it doesn't have any end behavior for the left. Okay. What about for the right? The limit as x approaches infinity of f of x will be what? Where is it going to? Infinity. Good. And then last but not least, increasing or decreasing. What can you tell me about the graph? Increases. Where does it increase from? Do I include 0? To where? So is it decrease anywhere? No. So what we have all done in this problem is this is everything we've done this year. We've combined it into one step. Okay? So we started the year with domain and range. We then went to intercept symmetry. We talked about continuity and behavior, and last but not least, increasing or decreasing. So this is your whole year that we've done so far in one problem. Okay? We're going to look at another one of those, but I think I'm running, well, I think I've got one more time. I think I'd probably better call it good for the video, and I will pick up again with another one.